Okay, hi everyone. So today we will learn about the chapter 3, talking about the atom, molecule, and ion. Now let's look for these slides. Okay, uh, as I said, we will learn about the atom, the structure of the atom, subatomic particle in atom, then the molecule, and the ion when it's used or gain electron. Okay, let's go here to this slide. Okay, now you need to know in each atom there is tiny sub atomic particle. Okay, it's called proton, neutron, and electron. So we have the proton. So the proton, which has positive electrical charge, has a symbol P with a positive charge. In neutron, small n, this is a small p also. A neutron is a neutral, but it has mass similar to the proton. So the proton and the neutron has approximately the same mass. Now we have another subatomic particle, is called the electron, which is very, very tiny particle compared to the proton and the neutron. Look at here. Proton have a mass that is only 1 divided by approximately 2000 or 1836, that of a proton, and carry negative electrical charge. So here we have small e with a negative charge. Okay, these three subatomic particles exist in all the atom. And of course, what makes the atom difference? It is the number of the proton. If we have a different number of a neutron for the same number of a proton, we will have something that's called isotope. If we have different number of electron for the same atom with the same proton, will be forming ion, could be losing or gaining electron, which we will talk about it later. Now, you need to know, to calculate the mass of the atom, we will focus only on the number of the proton and number of a neutron. We will ignore the number of electron. We will ignore the mass of the electron here. Okay, why? Because the electron is very, very small, tiny particle, and we try to simplify the calculation, how to calculate very small particle, which is called the atom. It's not easy, guys, to measure or deal with the mass of a single atom because it's very, very small particle. So here you will see, like, we will use some type of calculation. It's called the atomic mass unit. Okay, AMU, atomic mass unit. This atomic mass unit represents neutron or proton because they have the same mass, but we ignore the electron because it's very tiny particle. Okay, now let's keep going and go to the other slides and show you the mass of the proton or the neutron or electron. Okay, so here we will have this table over here. The proton has this mass in a gram, 1.672622 times 10 to negative 24, sorry. Okay, this in a gram. And look to the neutron, approximately the same. There is a little bit of difference. But look to the electron, it is 10 to negative 28. So it's very small. So here, they consider each mass of a proton or a neutron, we will call it atomic mass unit, AMU. Atomic mass unit, it is the unit for describing the mass of an atom based on the mass of the carbon-12 atom. So here, for example, this is the mass of the proton. This represents approximately 1 atomic mass unit. This is the mass of the neutron. It's approximately 1 atomic mass unit. But the electron, it is 10 to negative 4 atomic mass unit. So we will ignore it. But electron is still important because it has a charge. Still, electron, important subatomic particle because it has a charge. Okay. Now, okay, so let's go to this slide. Proton and neutron are packed closely together in a dense core called the nucleus. So inside the nucleus, which is this one, you will find the proton and neutron. outside this nucleus, it's just empty space, electron move on it. Now, look to this very, very small particle or small space, sorry, here in the atom. This represents the mass of the atom. Why? Because it has the proton and neutron. We agreed that we will ignore the electron. Here, outside the nucleus, it's just a space, empty space, and the electron moving on that space. And the electron mass, it doesn't affect a lot because it's very, very teeny particle compared to the neutron and proton. So we will just focus on the number of the proton and neutron in this very small space here. Okay, now, for each element in the periodic table, you will see there is two numbers. One number is called the atomic number, and the other it is the mass number or atomic weight. The A, which is the mass number or atomic weight, represent the number of a proton plus the number of a neutron. Now, of course, each of them represent one atomic mass unit. That means if I have one proton, one neutron, I will have the atomic weight or the mass number. Here, the mass number. The mass number will equal 2. What does that mean? Does that mean 2 grams? No, guys. This is 2 atomic mass unit, 2 AMU. What this AMU? It is a unit which equal this mass, this real mass. So here, 1.672 times 10 to negative 27 kilogram. So if you need to find the real mass, for example, in kilogram, so you have to multiply the 2 times this one, this number, and you will get the mass in a gram or kilogram. So here, when you will see this number in the periodic table, like for example, the atomic weight, 15, it doesn't mean 15 a gram, okay? It could equal 15 gram when we will talk about the mole later, but right now, what this 15 atomic mass unit, 15 AMU. What this AMU, it is this mass. It's approximately the mass of the proton or neutron, which is approximately close to each other. And look at here, we didn't calculate the number of electrons here because it's very small. Electron is 2,000 times lighter than a neutron or a proton. Okay, now another number here, the Z. Z could be equal the number of a proton or electron in neutral atom. Be careful, guys. In neutral atom. What's mean in neutral atom? It is the atom doesn't have a charge, positive or negative. The charge is 0. Okay, so here we have A, which is proton plus a neutron. Z, it is just the number of a proton or even electron if it's a neutral atom. Okay, now we will use this information to calculate the number of a proton or a neutron in each atom, or number of electron, or the mass number of the atom, or Z, which is the atomic number. Be careful, atomic number represents just the number of a proton. Okay, now let's see this table, which represents the periodic table that we have the element on it. Right now, if you see like this is empty, right now we have 118 elements in the periodic table. This part here, the beige color represent the metal. Be careful, hydrogen, we have to put it here to give the periodic table a good shape, perfect shape, but it's non-metal, okay? The non-metal, it is in this green color. This pink or purple color element is called metallites. The zigzag line, it is the metallites. The left side of the zigzag line in the periodic table represent metal. Be careful, here we have two groups or two periodic actinide and actinide. And here, it's supposed to be here. These represent also metal. In the right side of the zigzag line, the green color here, it is the non-metal. And let's keep going and see here. Okay. We learn how to determine right now the proton, the neutron, electron. Okay, we will use this table, periodic table, to answer this question. Okay, guys, I already posted the periodic table also in the module in the Canvas, so you can use it, which has all the 118 elements. Okay, now look to this question. What the type of this question it will be like for the subject? For example, how many proton, neutron, and electron are in atom of AU? Go back to AU. Now, guys, this A, which is the atomic number, the mass number A, will be in the top corner usually. Z, which is the atomic number, in the bottom, okay, on the left side of the element. So this number in the top will represent the mass number. This number in the bottom will represent the atomic number. Now, look here. We have AU 197. 197 represents the mass number for AU. Okay. Now, AU, this one here, some periodic table, they just show you the atomic number. Some periodic table, they give you both the atomic number and the mass number. The periodic table that I posted in the Canvas has both numbers, A and Z. Okay, AU. AU has 79 atomic number. And here they give it you 197, the mass number. They need to know the number of a proton. Look at here, guys. The mass number, the mass number, yes, 197, which represents A. Z here, they didn't put it, so it is 79. Okay. Now this is Z, this is A. What we learned? The Z represents the number of a proton, and also represent the number of electron if it's a neutral atom. There is no charge here in the AU. A represents the number of the neutron plus a proton. Now, Z79 represents the number of a proton. So here you will have this equation, and plus 79 equal A, which is 197. Do the math, and will equal 197 minus 79. Do the math, and we will get here will equal, okay, you will equal 110, 108. No, sorry, 118. 118. Okay, just double check the math. Okay, I didn't use a calculator, but I think it is correct. 118. So 118, it represents the number of neutrons. So the proton, 79. A neutron, 118. Electron, it is the same number as a proton because it's in neutron. So it will be also 79. Now let's do the same things with strontium. Look here, strontium -90. What does that mean? This way, especially they use it for the isotope, represent the A, the mass number, or the atomic weight, the mass number or the atomic weight, which is A. So strontium 90. Now I need to know the atomic number for strontium. Go back to the periodic table and look for strontium. So here you will find strontium, which has the SR symbol. Okay. By the way, the periodic table that I give you in the Canvas also has a name, just in case if you are not familiar with the symbol until now. Strontium 38, the Z, the atomic number. Here, strontium 90, which is the A. So I have SR 90 and 38. This represents Z, represent number of a proton, and represent number of electron. So I have number of a proton and electron. What about the neutron? This A. A equal proton plus the neutron. A, it is 90. P 38 plus N. Now N mathematically will be 90 minus 38 and equal 52 in neutron. So I have 52 neutron. So that's how we will deal with these types of calculation. Guys, try to practice with the other question that I have here. We have a lot of example also in the PowerPoint slides in Canvas. Okay, so also I want you to practice with example 2 here and example 3 here. The same one. Okay, now let's look what we have in the other slides. Okay, isotope. Isotopes, it is the same atom or atom of the same element with different masses. Now, who is responsible about the identity of the atom? It is the proton. The proton, it is the one who will identify the atom. If you have, for example, 6 proton, you have carbon, 7 proton, neutron, 8 proton, oxygen. You have 11, you have a sodium. So look here, the number of a proton identify the element, decide what type of element. Now, here they said it is the same element. That means the number of a proton will be the same. There is no change. But look what they told you, different masses. How we have different masses? A, it is a mass, will equal proton plus neutron. So if this is the same here, and here we will have different masses, that means we will have different number of neutron. The number of neutron will be different. So the isotope has the same number of proton, but different number of neutron. Let's look to this example here for the carbon. We have carbon with the atomic or the mass 11, carbon with mass 12, carbon with mass 13, carbon with mass 14. Now, the number of proton, 6, 6, 6, 6. So it is the same because it's carbon. No difference. Number of electron, if it's neutral, there is no charge here, 6, 6, 6, 6 also. Now, what about the number of neutron? Because it's isotope, here will be 5 of neutron, 6 neutron, 7, 8. How you will find that? Remember, A represent B plus N. If it's A, 11 for this one, equal proton 6 plus neutron. Neutron will equal 11 minus 6 and give you 5. Now for 12, we'll do the same thing. 12 equals 6 plus N. N will equal 12 minus 6 and give you 6. That's why we have 6 neutron. If it's 13, will equal 6 plus N and N equal 13 minus 6 and give you 7 in neutron. And that's why we have 7 neutron. The same things with the last one. So these we call it isotope, okay? Now, this isotope is very important to calculate the average atomic weight. So the number that we have it in the periodic table as an atomic weight, or the mass number, represent the average atomic weight for all the isotope for that element that's found in nature. So look at here. So for this, let's look at here. The atomic weight or the atomic mass will equal summation of mass of isotope times the fractional abundance. What is the fractional abundance? Fractional abundance is mean the percentage of that element or isotope in the nature. So here what we will have, and this is summation. Let's say, for example, we have 2 isotopes. So the average atomic weight or atomic mass, we'll calculate it like this way. The mass of first isotope times percentage of first isotope. Now, plus, we said we have 2, plus the mass of second isotope times percentage of second isotope. Okay, it is summation. If we have a 3, keep going, plus, don't forget these parentheses, it is the mass of that isotope times the percentage of it. Okay, we said if we have 3, will be mass of third isotope times percentage of third isotope. If you have 4, you will add for the 4, 5, 6, whatever it is. Do the math, and you will get the average atomic weight, average atomic mass. This is very important, guys, okay? And definitely, we will have some question in the homework, the quiz, or the exam about it. Definitely, this chapter is very important, okay, with these calculations. Okay, now let's look for the example. The next page, how they calculate the average atomic weight for isotope. Let's assume we have this element neon 20 and neon 21, neon 22. We have 3 isotopes. This is the math for neon 20, 19.992 atomic mass unit, and the percentage is 90.47%. Neon 21, it is this math exactly, 20.991 atomic mass unit, and the percentage is 0.27%. Ne22, it has a mass of 21.994 atomic mass unit, and the percentage 9.25. Now be careful, guys. Some example, some question, they don't give you this 19.99 atomic mass units, for example. Okay, they just give you Ne20, Ne21, and Ne22 with this percentage. In that case, if you don't have the exact mass, you will use these masses. So Ne20, that's me, I will use the mass of 20, which is very close to this mass. Look at here, 19.992. Okay, you don't have the 21 mass, which is 20.991, use the 21, it is fine. But if they give it to you, no, use these exact mass. So here they give it to me, so I will use it. So look at here, you will multiply the mass of the first one times the percentage. Be careful, guys, this is percentage. So this is 90.47 divided by 100. Don't forget it, it is a percentage, okay? I have some students who know what they are doing, but they forget the 100 and they get a wrong answer, so be careful. This is for the first, this is for the second, this is for the third one. Do the same things. Add them together. Look at here, we add them together and we will get the 20.18 atomic mass unit. If you will go back to the periodic table and look for the atomic weight or atomic mass or mass number for the neon, you will see it very close to this one. Of course, we need to round up the number to simplify the calculation. For example, the periodic table that I give it to you in the Canvas, it has a 20.2. So they just approximate this number, round up this number. Okay, but this is how we calculate the average atomic weight for all the atoms. Okay, you will do this calculation. Of course, you will know which isotope, what is the mass of that one, and what is the percentage. Of course, we have something, it's called the mass spectrophotometer that will help us to calculate the mass of that element or isotope and the percentage, okay? I think we have here another example. Look here for the gallium, the same things. We have 2 isotope, gallium-69, which has this percentage and this mass, 68.9257 atomic mass unit. Gallium-71 has this percentage and this mass. Now, what we're gonna do, the mass of the first one times the percentage divided by 100, don't forget, and the mass of the second times the percentage. Add these masses together, you will get the average atomic mass for that. Okay. Now, let's look. Of course, we have some example. We have many examples in the PowerPoint slides in Canvas. Try to practice with these guys. It is very important. Okay, now this is also about the isotope and average atomic weight. Okay, now Guys, just one thing. Be careful, guys. Don't, when I ask you for the average atomic weight, just use these two masses and add them together and divide it by 2. No, that doesn't work. So for example, if I have these two masses, okay, two isotopes, and I ask you for the average atomic weight, don't just add them together and divide it by 2. I have some students who do that. This is totally wrong. We have different ratio, different percentage, sorry, for the element. So what you need to do, multiply that atom, that mass by the percentage, plus the second one mass by the percentage. So be careful. Okay, now, what do we have here? We have we learn about the atom, isotope. Now for the ion. What about the ion? How you will get it? When the atom lose or gain electron, we will have ion. That ion could be either cation, which is a positive ion, or anion, which is a negative ion. Here in the periodic table, we will have the most common positive or negative ion. Now, how many electrons do the following have, and which noble gas has the exact same number of electrons? You can know, by the way, for some element, especially if it's in the main group element. The main group element, guys, is group 1, 2, this is a 3, 4, 5, 6, 7, 8. We have 8 main groups. This is the transition metal. Also, we have lanthanide and actinide below that. I'm talking about the element in the periodic, in the main group. 1, 2, 3, 4, 5, 6, 7, 8. Okay? This number 13, 14 is different system for the number, but I'm talking about these 8 main groups. You can know for most of them how many charge and what kind of charge, positive or negative, they will have if they form ion by comparing the number of electrons of that element or that atom with the closest noble gas and see how many electrons need to gain or lose to have the same number as the noble gas. What does that mean? Let me simplify it for you. And why noble gases? Noble gas is the most stable element in the periodic table. So all other atoms here, or elements, they try to be similar like the noble gases in the number of the atoms. So look at here. We have, for example, calcium. Calcium has 2 positive charge. Why calcium has 2 positive, not 1 positive, not negative? Why? Look to the location of the calcium. Calcium here has the atomic number Z20. Now, you will compare the calcium with the closest noble gas. Which noble gas is close to calcium? Don't tell me krypton. Krypton here is 36. Look to the difference between them. It is 16. Okay, difference between them. Argon here, okay, it is the closest to it. So argon here will be the closest to the calcium. So calcium, 20 atomic number, argon, 18. Now calcium to be similar like argon in the number of the electron, need to gain or lose electron. Calcium here 20, need to be to 18. So calcium will lose 2 electron to have 18 electron like argon. Now one is losing, that means it is a positive charge. Now how many electrons lose? 2, so it will be 2 positive. Look to sodium or aluminum. Let's do this example. Aluminum is here, has 13 atomic number, has 13. Neon, it is 10. This is the neon, which is the closest noble gas. Okay, 13 close to the 10, not 18. The argon is close to the 13. Okay, so neon is 10. Now, aluminum need to lose a 3 electron to have aluminum 3 positive, like neon in the number of the electron. Now, the same things for the negative ion, look to the sodium, not sodium, sorry, nitrogen. Nitrogen has 7 atomic number, close to neon, which is 10. Now, nitrogen need to gain this time 3 electrons. Because it's gain, nitrogen will have negative charge. How many electrons? 3, so it will be 3 negative. That's how you will know quickly the number of the charge, if it's positive or negative for these elements, or we have some common ion here in this periodic table. You can just memorize them. We don't have a lot. Okay, but as I said, this way it's also easy to be sure that the charge of the element is correct or not. Okay, now for the covalent compound. By the way, we have ionic compound when there is losing and gaining electron. We will have ion, positive and negative. They will attract each other and they will form the ionic compound. Now we have some types of compound. It's called covalent compound. These covalent compound, they don't lose or gain electron. They share. They share the electron together. Okay, like these elements. Now the non-metal element here, they form these covalent compound. The ionic compound, we will have a positive ion in the metal. Non-metal form a negative ion. So the metal, one non-metal, they will form ionic compound. Okay, now ionic compound, chemical formula or naming the compound. We will talk about this in a separate video, how you will name or get the chemical formula for ionic compound or covalent compound. As I said, guys, try to practice a lot with a lot of example we have in the PowerPoint slides in Canvas. Okay, see you in another video.